compression ratio. When we talk about the compression ratio, the formula we're using here is the swept volume. So that's the amount of air that's displaced from bottom dead center to top dead center. That's that sweeping volume that we're displacing as the piston moves. Then we actually add in the clearance volume. The clearance volume is any volume that's above the top of the piston to make up the combustion chamber. In a diesel engine, the combustion chamber is established in the head of the piston. So there is a volume that is in there, and we establish that as our clearance volume in a diesel because they typically do have a very low clearance volume. So the swept volume plus the clearance volume, and again, we always divide it by the clearance volume. So no matter how much we have with the sweeping movement and the available room on the top of the piston head or in the cylinder head as the combustion chamber, we always divide it by our available clearance volume that we have. And that's how we come up with what's called our ratio of how much we compress that sweeping volume into the available clearance volume at that ratio. So if we plug in some numbers from prior formulas, 103.14 for swept volume, and I've gave a value of 6.45 cubic inches for our clearance volume. If we add the two together on the top, it calculates out to what is also known as our total volume. And again, our total volume is always divided by our clearance volume to give us our ratio, which we're looking at here. Sometimes we may have just a total volume from the manufacturer, and when we have that total volume from the manufacturer, then we can just divide it by the available clearance volume to give us our ratio. In most cases, we're going to have numbers like this, which is our swept volume plus our clearance volume, which now I have calculated out to as 109.61. And again, we divide that by our available clearance above the piston, which is 6.45 cubic inches. So if we take our 109.61, which is our total volume, divide it by our clearance volume, total volume divided by clearance volume, gives us a value of 16.99 to 1. So when we take this and we divide the top into the bottom, we're establishing how much we're actually compressing that swept volume into that available clearance volume. So that's the ratio of compression of that volume into that small space. And that's established at 16.99 to 1 complete swept volume movement.